All right, let's take a look at today's lesson. So we're starting a new unit on conic sections. And what they like, and you may have seen these diagrams before, how the conic sections are created from cones. This strange looking thing right here is called a double napped cone. Not that you have to memorize that. I mean, that's what that is. So as you slice through it, you create, you can see this green one right there. That's a parabola. Hyperbolas have two pieces. This is a hyperbola. These pink ones, that's a hyperbola. Circle would be slicing straight across, and an ellipse would be slicing at an angle. Those are the four kinds of conic sections we're going to deal with primarily. We do have other kinds of conic sections when, I don't know how you want to think about it, when it's sliced strangely. These are called degenerate conics. We really aren't going to focus on degenerate conics this year. These are in the form of a conic, but they don't create a circle, an ellipse, a parabola, or a hyperbola. They create other things. And so I'm just going to talk about them. We're not going to really work with them or find them out. I just need you to understand that is a thing and that, about it. But we're not going to actually physically work on it. So this is an example. This is degenerate. So if we were, this is just the scenario. This is what happens. So the degenerate form of a circle is a point. The degenerate form of a parabola is a line or two parallel lines. Ellipse is a point, and a hyperbola is two intersecting lines. You don't have to memorize that. It's just information for you to understand that there is another kind. There are other kinds of conics that aren't these regular ones. We just won't have time to deal with them. Okay? All right, so we have two forms of conics. One is called the general form, and one is called the standard form. Here we can see the general equation of a conic is all written out like that. Ax squared plus cy squared plus dx plus ey plus f is 0. That's a general form. Typically, your problems are going to be given to you in general form. One of our jobs is going to be to change them into standard form. Now, these formulas right here, in a typical fashion, we would memorize them, but we are not going to memorize them this year. I'm going to give you just these formulas. There are other formulas involved, and as we go through the notes, I'll show you the other formulas. I'm not going to give you those, but I am going to give you these. You do not have to memorize these. These are the specific formulas for parabolas right here. And this is the formula for a circle, which you may already know perhaps from geometry. Here are the formulas for ellipses, and these are the formulas for hyperbolas. Those are the formulas, so I'm just going to write a note on here. These will be given to you. Of course, I'm not going to tell you which one is which. You'll have to know, and you'll have to know how to use it, but you don't have to memorize the formula. These formulas, these 1, 2, 3, 4, 5, 6, 7, these 7 formulas you will get. Any other formulas you come in contact with, you're going to need to memorize. Okay? All right, so this is just an overview. This first page is an overview of all of the different kinds of conics. We're going to practice this just one thing on this page where we're going to put something that is in standard form or in general form into standard form. That's what our practice is here, and then we're going to get into parabolas. Today is the day we work with parabolas. So let's focus on putting things in standard form. So let's take a little note to change from general to standard form. You complete the square for x and y. Okay. So to change from general to standard form, it requires you to complete the square. for x and y or x and or y, depending on how many of these little squareds you have. Okay, so let's work on that. So what would we do? What's our process? So you know how I like to write steps. So the first step is to group like variables together. Like x's with x squareds, that kind of thing. You want to group them together. 2, you move the constant to the other side of equal sign. I'm going to pause there for just a moment. So number 1, this is the steps that we're going to use to go from general to standard. You're going to group like variables together, like x with x squared, y with y squared. You're going to move the constant. We all know what that vocabulary word means, right? Constant is just a number, like 5 or something, to the other side of the equal sign. Okay, so let's do that first 2 steps first. So I've got 9x squared minus 18x. I'm grouping the x's together. Then I've got 4y squared plus 16y. And then I'm going to move the constant to the other side. It's a negative 11. When I move it over, it's a positive 11. That's step 1 and 2. Okay, I'm just pausing. Are we okay? Step 3, complete the square and normally it's needed. I'm just going to write down if needed. Now, if you've got 2 terms, I mean, you need to. The only time, so let me just be more specific because I don't want you to be confused. If needed, we'll just put, I'll put it, it'll be a little easier. If you have 2 x's like x squared, or 2 y's like 2 of them, or 2 of y's like y and y squared, you know. That's when you know you need to complete the square, when you've got these 2 things, right? If it just said 9x squared and there was no 18x, we wouldn't have to complete the square, but that's going to be rare. But I need you to understand that you wouldn't have to if there wasn't this extra x there or this extra y. Okay, so completing the square, that's a whole process into itself. We learned it last year. Perhaps you can see your notes from last year. You can take a look at the completing the square. I'll remind you that, let's see, just little bullet points. The leading, if the leading coefficient is not 1, you must factor out of specific variable, like out of the x or y, not both. You factor out of the 1. So we've got that going on, so let's practice it. So I've got a 9 right here. I'd factor the 9 out. That leaves me, I'm factoring is dividing, remember. 18 divided by 9 is 2. And then I leave a space right there. If you recall from last year. Let's see, do we all have our, come back little thing. Do we all have our steps complete? Okay, so then we do factor of 4 out. And that gives me y squared plus 4y. Leave a space and make 11. Okay. Then the second bullet point for completing the square, you take half of b. Okay, b is this. I'll just highlight. That's b. you take half of b, then square it, then add to both sides. Note, if leading coefficient, I'm going to write leading coefficient. If leading coefficient was not 1, you must adjust the number you are adding to the right side. And I'm going to show you that in just a moment. So take half of b, then square it, then add it to both sides. Note, the leading coefficient was not 1 and you had to factor it out. You have to adjust the number you're adding to the other side. You may or may not remember this from last year, but we're going to practice it. Okay, does everybody have the text written down? All right, so let's practice that. So we take half of 2. Half of 2 is 1. 1 squared is 1, so I add 1 here, but I'm not really just adding 1. I hope you can see that I'm really adding 9 times 1, or 9. So I'm actually going to have to add 9 over here. That's what I mean by adjusting it. It looks like I'm adding 1, but I'm really not just adding 1. How did I change the value of the left side of the equation? I changed the value by 9. I added 9 to that side. I know it doesn't look like that, but we need to be clear. So now on the y's, I take half of 4, which is 2, square it, which is 4. So I add 4, but am I really just adding 4 here? No, I am really adding 16. So plus 16. And I've got it color-coded so you can see where the numbers come from. That's where the numbers come from. So I'm going to pause here for a second. Questions? Okay. The next step, I factor, and I'm going to still call them the bubbles, just like I did last year, the bubbles, and clean up. Okay, so 9 is here. I'm factoring. This is always a perfect square. The whole thing with completing the square is because it's a perfect square. It always factors the same way. Always the same way. This sign is going to be the same as that sign. This number is always going to be half of that number. It's always the same. It's boring. Plus 4 times. Okay? Got my y. So half of 4 is 2. And now I'm just going to add up all those numbers. 11 and 9 is 20. 20 plus 16 is 36. And this is what I have so far. Okay, after we complete the square, our fourth step is to write in proper standard form. Write in proper standard form. This has to look like one of those 7 equations that I just highlighted in pink. It has to look like that. Okay, so let's look at the equations. Notice how we've got 2 choices. Well, I guess technically 3. We've got this choice where there's a first power and a second power. Those are parabolas. This is not a parabola. They're both squared. If it's not like this, where we have y or x to the first power and then x squared, to the second power, those are unique. We're either going to be equal to 1 are we going to be equal to an r squared? That's our only choice. Equal to 1 or equal to an r squared. That's all we got. So it's either going to be a circle or an ellipse or a parabola. And so here, our only choice, I mean, look, do you see any numbers right here? Are there any numbers outside of here? Is that okay? No, that is not okay. See, there's no number here. That's just a 1. I can't leave the 9 here. I can't leave the 4 there. Those are not okay. So my only choice is actually to, I can't do the whole circle thing. Circle thing isn't going to work. I've got to divide everything by 36 so that I'm equal to 1. So 9 goes into 36 4 times, so I have x minus 1 squared over 4 plus 4 goes into 36 9 times, y plus 2 squared over 9 equals 1. And now I'm in proper form. Now, we're going to go over ellipses at a different date. We're not going to do that right now. I just wanted you to be familiar with writing things in standard form as an overview. Okay, we're going to get a lot of practice with writing things in standard form. A lot of practice. By the time you're done with this unit, you will be so, it will be so easy for you to write things in standard form. It'll just be a piece of cake. Okay? Y'all are like, sure it will, sure it will. It will. All right, so now let's get into, this is an overview. Let's get into our parabola lesson. We've dealt with parabolas before. We've been dealing with them since Algebra 1. This is the definition of a parabola. It's a set of all points equidistant from a fixed point. It's got a focus, it's got a directrix. So let's get in here and let's label these things. Let's label what we're talking about. Okay. We are very familiar with vertical parabolas. We've been dealing with them for a very long time. Horizontal parabolas, not so much. Not so much. So let's go through the parts. Okay, this is called the focus. So I'm just going to label it with an F for focus. That is called the focus. Okay, it's a little dot inside of the parabola. It's the focus. It's a special place. The distance between the vertex and the focus is called P. That is a distance. P is a distance. I'm just going to write that down. P is a distance. It's actually the distance between the vertex. So this is a vertex. Right there, that point is a vertex. The vertex and the focus. It's also the exact same distance as between the vertex and the directrix. This is also P. That is a significant number for us. That's very important to us when we're dealing with parabolas. It's going to allow us to find equations of parabolas. So that's important. What is a directrix? Students always ask me, why do we have that silly dotted line there? What is it? I actually like to think of it as a balancing tool. I don't know what you would like. It's equidistant. So the focus and the directrix are equally distanced from the vertex. They're the same size. And in my mind, it seems like it helps it to balance. It's an important piece of information, especially when we do, which we won't do this year, if we did polar equations of conics. It's really important. The directrix is important. For us, it's just a little dotted line. It is not an asymptote. It is not an asymptote. It is a directrix. That is a different thing. Okay? So, this is a directrix. And we'll draw one over here. Those are the directrixes. Okay, they're just little dotted lines that are underneath the parabola. The parabola always goes away from the directrix. Okay, so we talked about the first bullet point. P is the distance from the vertex to the focus and the vertex to the directrix. Let's talk about the latus rectum. I call it the LR, or some books use the word focal diameter. What is that? It's actually a cool little thing, and I'm going to draw one on this other parabola since I haven't done much over here. So the focal diameter actually is the distance from one side of the parabola to the other through the focus. This goes through the focus. And it's kind of handy. It tells us how wide to draw our parabola. It's really kind of handy. This formula, you would have to know. I'm not going to give you this formula. You need to know that. And, I mean, I'm giving you the big formulas. I'm not giving you this little one. So the LR is absolute value for P. And this formula I want to rewrite is A equals 1 over 4P. This is a formula that shows the relationship. The relationship between A, which is this right here, and P, which is that right there. That's the relationship between A and P, this formula. These two formulas you would have to memorize. So let's put a star by them. You need to know that for parabolas. Two little baby formulas. The last piece I want to talk about is the value of A. And A will I'll just highlight it. It's right here. It's A. If A is positive, the parabola is going to open up or right, depending on which kind it is, whether it's a vertical or horizontal. If A is negative, then the parabola is going to open down or left. That's important information for you to know. It gives you an idea of what the graph is supposed to look like. So we have two more problems we need to do. One of them has to do with finding the equation of a parabola given particular information. The other has to do with the full out graphing of the parabola. Okay, and that will conclude the lesson, but we have two more things to talk about. I've talked to you about all different kinds of concepts regarding parabolas, what all these things mean, how to do things. Now let's practice. Let's go and let's do this first. Let's find the standard form of the equation of the parabola with that information. Now, my recommendation for you is to graph whatever they give you. I mean, I'm not going to make you. I'm not going to give you a grade for graphing, but if you don't graph what they give you, you're not going to have any idea what this parabola is going to look like or what it's going to do. So the vertex is left 2 and up 3, and I will just label it, that's my vertex. Okay, great. The focus is at 0, 3, and I'm just going to label it focus. Now, what do we know about parabolas? We know the focus is inside of the parabola. So I would think to myself, well, this parabola is going to have to open like that. It's going to have to open like that for the focus to be inside of it. If I didn't draw this, how would I know that? Would I just kind of like, I don't know, try to do it in my head? It would be really hard. I have seen students do these without drawing them. I don't know how they do it. Guess and check, I don't know. I recommend you drawing it. So this is going to be this is going to be actually a right opening parabola. So I'm going to copy down the formula. This is the formula that is up there that's going to be given to you. I'm just going to copy it down. Again, you don't have to memorize the formula. You just need to know what everything is. Okay? So the vertex, which is -2, 3, is actually H and K. That's what the vertex is. It's H and K. H is the X, K is the Y. I can do most of that equation by just sticking those two numbers in. Okay, well, let's do that. So I've got X minus a -2 would be +2 equals, I don't know A yet, I've got y, k is 3. Okay, that's fantastic. I'm almost done with the equation with just knowing the vertex. Now, I don't know what A is, but I do know there's a formula that relates A to P. A equals 1 over 4P. That's a formula that I would have memorized. Now, what is P? We need to think back to P is a distance. Do we remember what P is the distance between the focus and the vertex, right? So if I count these spaces right here, that's what, 2 spaces? So P is 2. Okay, fantastic. P is 2. And so also P opens right, or this opens right. So if we open right, A has to be greater than 0. That's something you just need to know. How would we just know that? Well, if I think about where it's opening, is it opening to the positive part of the coordinate plane? That's why it's positive, right? X is positive. If we go right, X gets more and more positive. So that's how we can remember that when it opens right, A is positive. So now my job is simply going to be to put that in my formula. P is 2, so A equals 1 over 4 times 2, or A is 1/8. And I have my equation. And I leave it like that. We don't need to put it in general form. Leave it in standard form, and we are good to go. Yes, ma'am.
So you don't do anything with the focus point?
Nope.
Okay.
It's just really, what it did is it gave us another piece of information that we needed, at least one more piece of information till we can find the equation. And that was just our tool. That was our tool to be able to find the equation. All right, how are we doing? You're probably like, oh, this is going to be the greatest unit ever. Okay, now the graphing. Let's go to graphing. Okay, our formula is in general form. Okay, so for parabolas, let's look and see what we've got so we can write the general form. So we've got an x to the first power, we've got a y to the second power. That's what we got. So let's go up here and see which one of those formulas has an x to the first power and a y to the second power. Okay, that's this one, right? X to the first power, y to the second power. We need to copy that formula down. That's what our answer should look like before we, go forward. So it should be x minus h equals a times y minus k squared. That's what I'm going for. That's going to be very helpful so that I can read information off of it. Okay, so I need the x on the left side. It already is. That's great. So let's just start moving it where it should be. So I've got 3x Okay, so I guess I should probably write steps out here. So number 1, move squared variable. This is for parabolas to right side. Squared variable and any other, those kinds. Number 2, move first power variable plus constant to left. Okay, that's for parabolas. We move the squared variable and its little brothers, sisters, whatever, to the right. We move the first power, like x to the first, and the constant to the left. So I've got 3x, and I've got the constant of 31. Then I've got moving the y squared over, and then I've got the 8y. Okay. Number 3, complete the square. Gosh, I can't write. Complete the square. Sorry for the messy writing. Okay, well, this time we don't have a leading coefficient of something other than 1, so great. We're going to take half of b. Half of 8 is 4. Square 4. 4 times 4 is 16. Add 16. Add 16. So let's see, negative 31 plus 16 is what? Negative 15. And then this is now a perfect square, which is y plus 4 squared. Okay, let's compare it. We're comparing this to this. We're almost there. We're not quite there. On my standard formula, do you see a number in front of the x? Nope, not the standard formula. I do in this formula I have here, so that's a problem. So I've got to make it look like that, so I've got to factor the 3 out. So 3 times x minus 5 equals y plus 4 squared. And then my last job is going to be to take this and turn it into, or I'm going to move it over here, right? I need to move it. So I'm going to divide both sides by 3. So my standard equation is going to be x minus 5 equals 1/3 times y plus 4 squared. Okay. My recommendation is for you to read the vertex out of this problem and write it right here and just plot it. The vertex is always opposite. So the one, remember I told you was HK? See how H has got the subtraction right in front of it? K has got the subtraction? H is 5, K is negative 4. 5 and negative 4, thank you. Does everybody understand where 5 is positive and 4 is negative? Okay, so I'm going to plot that over here. So I'm going to go 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. There's my vertex. Okay, great. All right, in order to find, other things, I need to be able to figure out where the focus is. I need to know where this is opening. Okay, I need to know where the directrix is. A is positive, it's sideways. So I'm just going to put a little note over here. We're going to open this way, right? I'm just going to put a little reminder here. This is the way we're opening, just to help me remember. How do I know that? Because I read it. That's the kind of equation it is. And A is positive. See how important it is to know all the little details. They are a lot of little details. Okay, we need to find P. So A equals 1 over 4P. A is 1/3. 1/3 equals 1 over 4P. Personally, I would cross multiply to find P. That's what I would do. So I have 4P equals 3, or P is 3/4. Okay, so what does that mean? Let me pause here for a second. I want to make sure everybody's got P is 3/4. That means if I go 3/4 to the right from the vertex, I'm going to have my focus. My focus is right here. So I'm going to write it down. My focus is at 1, 2, 3, 4. It's at 5 3/4 and -4. That's where my focus is. I encourage you to just write it off the graph. We're just writing things off the graph. The directrix is going to be 3/4 of space to the other side. The directrix is going to be right here, 3/4 of a space going this way. So my directrix is going to be, now, Okay, it's a vertical line. So is it an x equal or a y equal equation? Vertical lines, are they x equal or y equal equations? X equals. My directrix is going to be x equals 4 and 1/4, right? Because I'm 3/4 away from to the left of the vertex. Wonderful, wonderful. Our LR is, the formula is absolute value for P. So we're going to do absolute value of 4 times P is 3/4. So the LR is 3. Okay, I'm going to pause here for a second. That's the length of the LR, the lattice rectum, focal diameter, LR. So what is that? How does that help me? Okay, what I'm going to do is I'm going to come over here and I'm going to think about, so we're going to split this like it's a half, right? 1.5, 1.5. So I'm going to go 1.5. I'm at my focus right here. I'm going to go 1.5 up. And I'm going to go 1.5 down. And that is the length of my focal diameter. And I can now complete my graph. I start at the vertex and I just hit the focal diameter point. That tells me how wide to draw it. It tells me how wide to draw it. The length is the total length. The total length. That's why I need to split it in half. It's the total length. The axis of symmetry. Think about symmetry when we worked once. I mean, you've been working with symmetry for a while. Not necessarily in this class, but in geometry, other places. So my axis of symmetry cuts this thing in half, right? So it basically goes through the vertex. This is my axis of symmetry. This is, and they kind of like abbreviate as AOS, axis of symmetry. This is a horizontal line. So this is going to be a x equal or a y equal equation. A y equals -4. And now we can look at the graph and determine our domain and range. We're just going to look at the graph. Okay, the graph is, it starts at 1, 2, 3, 4, it starts at 5. Right, we start at 5 and we are at 5 and it goes all the way to infinity. Our range is -infinity to infinity.